Namaste, my name is Rishi. I'm studying in Sri Venkateshwar College of Engineering, class ISC USN 1VE 23 IS 042, third sem. Today's topic is applications of probability, subject mathematics. Probability, the foundation of design making. Probability is a powerful tool that helps us to understand the world around us and make informed decisions in a variety of situations. From financial market to medical research, probability plays a vital role in shaping our understanding of randomness and uncertainty. Introduction to probability concepts. First one, random events. Second one, sample space. Third one, probability. Fourth one is events. These are the concepts of introduction to probability. Random events, events with unpredictable outcomes like coin flips, dice rolls, or weather patterns. Sample space, the set of all possible outcomes for a random event representing the complete range of possibilities. For probability, a numerical measure of the likelihood that a specific event will occur, ranging from 0 to impossible. Events, specific outcomes or combinations of outcomes within the sample space. Classical and empirical probability. Classical probability and empirical probability, based on equally likely outcomes calculated by dividing the number of favorable outcomes by the total number of possible outcomes, is known as classical probability. Determined through observation and experimentation, calculated by dividing the number of times an event occurs by the total number of trials, is known as empirical probability. Probability distributions is done in three ways: normal, binomial, and Poisson. Normal distribution its description is bell-shaped continuous distribution symmetric around the mean. Examples: height, weight, blood pressure. Binomial, discrete distribution for the number of success in a fixed number of trials. Coin flips, number of defective items in a sample. Poisson distribution, discrete distribution for the number of events occurring in a fixed interval or time or space. Number of customers arriving at a store, number of accidents on a highway is the example of Poisson distribution. Conditional probability and Bayes theorem. Conditional probability, the probability of an event occurring given that another event has already happened, is known as conditional probability. Bayes' theorem, a formula that updates prior beliefs about an event based on new evidence, is known as Bayes' theorem. Applications: medical diagnosis, spam filtering, and weather forecasting is used for Bayes' theorem. Law of large numbers and the central limit theorem. Law of large numbers: as the number of trials increases, the average of the results will converge towards the expected value. Central limit theorem: the distributed of sample means will approach a normal distribution regardless of the underlying distribution of the population. And the applications of the DCCB is the application: sampling, statistical inference, and hypothesis testing. Law of large numbers and central limit theorem. Applications of probability in finance: portfolio management, risk assessment, option pricing, financial forecasting. In and many ways we can use the probability in our daily life. Portfolio management. Probability is used to access risk and diversify investment portfolios. Risk assessment. Quantitative methods like value at risk use probability to measure potential losses. Option pricing. Black-Scholes models utilizes probability to value financial options based on underlying asset price movements. Financial forecasting. Probability helps in predicting future stock prices and market trends. Probability is used mainly in stock market and and its applications are mainly used in all the stock market and other stuff. Probability in quality control and risk management. Process control, risk assessment, and decision making. These are the quality control and risk management used by probability. Process control, statistical process control uses probability to monitor and improve production process. Risk assessment probability helps in identifying potential risks and estimating their likelihood and impact. Decision making. Informed decisions are made based on probability analysis of potential risks and consequences. Probability in genetics and epidemiology. Genetic inheritance and disease transmission is also used here. Probability is used in various stuffs, like here in genetic inheritance. Probability helps calculate the likelihood of offspring inheriting certain traits from their parents. Epidemiologist transmission. Epidemiologists use probability to model disease, understand factors affecting the transmission rates. Conclusion. Probability impact across disciplines. Probability is a foundational concept in many disciplines, providing a framework for understanding randomness, uncertainty, and decision making. From finance and medicine to genetics and engineering, probability empowers us to make informed decisions, manage risks, and advance our understanding of the world. Thank you. Please do like, share, and subscribe. Visit again.